Hi everyone, dear friends. I'm happy that you are all here with us now, and I'm sure that today's part of our program will be as busy and interesting as the previous ones. My name is Anton Sokolov, and together with you today we will continue our journey over the world of the artificial intelligence. Today we're going to speak about how to work with artificial intelligence and how to study this subject. I would like to give the floor now to Evgeny Sokolov, Deputy Head of the Department for Big Data and Information Search, Chief Lecturer of Computer Sciences Faculty Department of National Research Institute, Higher School of Economics. Evgeny is going to make an overview and introduction into the machine learning and artificial intelligence. Will tell us how it works and how you can study the subject. Hello, my name is Evgeny Sokolov. I work in the Higher School of Economics at the Department of Computer Sciences, and in this lecture I will speak about what machine learning is all about and what you should know to be successful in this area, what professions exist in this industry, and where you should focus on if you want to get deeper into the area, into the field. To know what it is all about, we should get deeper into the whole thing. Let's take a task, and I'll tell you how it can be resolved through all these methodologies for us to be able then to speak more about what you should know about the industry and where you can study it. So let's just take the following task. For instance, we have a course. I read lectures at this course, and we have 500 or 600 students at the course, and I collect feedback from students. I'm interested in whether they like my course or not, and since there is much feedback, it'll take time to read all of them, all the feedback, to know whether the students like my course or not. And I can save time if I can automatically understand from the text of feedback, understand whether it is negative or positive, and then I can calculate the amount of negative feedback, and this will be an indicator whether my course is successful or not. So these are the real feedback. You can have a look at it now on the slide. The students were speaking about our course, some positive, some negative feedbacks. At the same time, words are very different, and different words can actually show you whether this text is positive or negative. So let's just define the tonality, the tone of the text. Yes, of course, you might think of the following now. Why creating something difficult? Why speaking about artificial intelligence in such case? We can create rules. For instance, if the text says that the course is bad, it means that the student is not satisfied. If the text contains a word good, it means that the student is satisfied. But if we add such rules, they can mark up our text in terms of the tone of voice and other characteristics of the text. But no, the experience shows that tackling such tasks, the word methodology doesn't work effectively enough, and you cannot make decisions whether the text is positive or not by just separate words. If we take the word bad, a student can say this course is bad, or he can say that it is bad that the course is so short, I want more of it. And obviously this is a positive feedback, and the student is sad that the course will end soon. So how can we explain this with rules? It's a challenge indeed. And yes, sometimes people are quite sarcastic or ironic, and their texts are harder to analyze, and it means that we need more serious methodologies to analyze such texts. So let's just articulate a task. We want to set up a function, a of x. We can call it model or an algorithm. These are synonyms. And this function, as an input, takes a piece of text, and as an output, it gives us two digits, -1 or +1. -1 if the text is negative, +1 if the text is positive. Well, this slide might provoke a lot of questions among you. First of all, well, have you seen functions that take a piece of text as an input? Probably no. In maths, we usually look at figures, f of x or x squared, or a lot of various values in one equation, and various other terms. We know how to deal with functions with figures. But functions of text, This is something strange so far. Next, this function is giving us -1 or +1. Again, if you only faced school maths so far, probably functions you've already seen give us a figure, but discrete functions that give you as an output -1 or +1, probably you haven't seen things like that before. But let's sort this out and let's speak first about the first problem I articulated. We do not know what this function of text is all about. Actually, the approach in machine learning is usually as follows. We have complicated objects that we analyze, text or images or sound or something like that, and you need to describe these assets, these objects through characteristics or figures, with which then it will be more convenient for us to tackle the task. And these characteristics we use are actually called features, and we need to create figure characteristics for our text we're analyzing, through which we can understand whether the text is positive or negative. And here, yes, we can create a lot of various features, but one of the most simple ones and typical approaches when working with text is a bag of words. What is it? Let me give you an example. Just imagine we have 4 texts. You see them on the left part of the slide. A is the first one. So someone is too emotional when offering feedback. The other says cool lectures. The other says no fun. And the last one says the course is cool. Let's just create a vocabulary of all the words that we can see in these texts. Unique words. There are 6 of them now. If we do not look into the forms of words, if we just take them as they are, 6 words. It is wow, A, lecture, cool, fun, not enough, and course. You know, cool, we see the word cool in 2 texts and we take it one time. And now let's code every text in the following way. I have 6 words that I can see in the text, and let's have 6 features, 1 per each word. And a feature that goes together with the word will show us how many times we see the word in the text. I have cool, and then I have 1 in the columns lectures and cool, and another text no fun. Then I will have 1 for fun and 1 for other features. So I'm describing the text by these digits, and this is called a bag of words. Why? Because when we code our text in this way, we fully lose the sequence of words, and through these 6 features, we cannot restore the whole text. We know that we see the word cool 5 times and the word course we witnessed it 10 times, but how they were combined, were they standing next to each other, or otherwise, we do not know. We lose the sequence of words, but the word order. But for many tasks, it is not as important. When we try to understand the tone of the text, indeed, the words we have is important, and sometimes it is quite enough. If it is not enough, then there are means to make this coding more difficult, more complex, and use bigrams or trigrams, but this is a separate discussion. But I think you understood the idea. We should create the features that can describe the text, and that's where we create our bag of words. And this stage of creating the features is quite important and quite time-consuming, and it takes much time. When specialists work in projects, it takes much time to create and develop the features. So let's think it over. Just imagine a task of predicting firing people. We are working in a large company, for instance, with hundreds of thousands of employees, and we want to know in a centralized manner. We want to forecast that this person, for instance, wants to go away leave the company. We probably can talk to him or raise salary. What are the features that are important here? Probably the information information on how, when he was promoted last time and his salary was raised, and information on whether he went through courses for improvement of his qualification, and information on how he uses the insurance offered by the company. There is a hypothesis saying that if an employee starts actively using the insurance and is treating his teeth for 2 months, probably it means that he's going to leave the company, because when he leaves, he does not have this insurance plan. So probably there might be other features, but you should think of what they might be. And if a client of a bank wants to buy a car, we should be ready to offer him a loan. Again, you can create features looking at and analyzing transactions on the banking card of this person and look at the previous purchases of this person. So you need to think it over and make experiments. If we want to evaluate the price of an apartment by its description, also we should create features of such apartment explaining why it costs so much. So if you're interested in real estate market, you know that prices are very different, and you need a lot of features to explain why such price for an apartment. So this is an important part, so let's not forget about it. Next, we created features, and now our texts are described by a number of figures, and we can get back to functions we got used to. For those from maths we got used to and we're working with them, we should not be afraid of a function we need to create that will be defined by text. Now we are going into figures. Yes, there are a lot of options in machine learning. What features to use and what models to use. So let's speak about the most simple one, the linear model. The idea of linear model, if describing it in plain words, is as follows. We take the features, we multiply the features by ratios, by weights, and sum up what we have, sum up the results. If you are aware of higher maths and linear algebra and linear combinations, you are aware of the term linear model. If we take it as a formula, it is at the top of the slide. If we have something in square brackets, then it means that I put how many times this word is in the text, is witnessed in the text. So I am taking the word a or wow and multiply it by minus v1, or I take course and multiply it by its weight, and I sum up all these things. So in this example we have 6 words. That's why we have 6 parts of the equation. If it is 10,000, then this formula will have 10,000 elements. Yes, sometimes we add free ratio b or double v0, but let's not get so deep into details. It doesn't matter for this particular case. So the ratios, the weights that are shown here are parameters. They're called parameters, and they define how efficient this model will be. I can set the parameters in a way that the model is very bad. I can set them in a way that everything works smoothly. And our task is to learn how to learn and understand how to find the proper weights, values for these weights, and the model will work effectively. So I described the formula, but I didn't say anything about how we predict with this model. So I take the weights and I make the sum of it, and I look at the value I have. If it is a positive value, I can say that my text is positive. If the value is negative, then the text is negative also. So this is a very simple approach. I'm just looking at this weighted sum, looking at how many times I see various words in the text. Seems quite logical. If the weight is positive with a word, then it means this word is just dragging the forecast into a positive side. If the weight is negative, it means that this word drags the whole text into the negative side. And then I sum up the weights and the tones of various words, and that's the result I have. So it looks quite logical. But For instance, I have 6 words and I assign weights to these words. Lecture means 0. It means that this word doesn't impact the tone of the text. If someone is speaking about lectures in his text, doesn't show us whether he likes the lectures or not. But if he says not much, then the weight is negative, -3, because probably yes, this word means that this person is not satisfied, but not in all cases. And the forecast for this model for various texts can be calculated. For instance, cool lectures. Lecture is 0, cool is 10. So I sum up the two elements and I see that the value is positive and the text is positive according to the model. If they say no fun, so no fun, I have as a sum -2, and this means negative text. From the point of view of the model, I just take these weights randomly. I do not want to say that those are definite values. No, this is just an example model, and we calculated a forecast through this model. Okay, fine. Next question is, how can we understand? For instance, we take random weights. Are they good or not? Not clear yet. Let's sort this out. Here we see a very important concept in machine learning, speaking about the learning sample. Those are cases of tackling tasks. Such sample is text where I know the right answer to. Logically enough, if I want to check whether my model is efficient or not, I need texts I know exactly whether they are positive or negative. That's why I need such training sample to assess the quality of the model. Formally, this is a set of pairs from the text and the proper answer. There might be a number of such pairs. I can have 100 texts where I know exactly the tone of, and there might be millions of such texts. Well, I will need it anyway. And creating features and accumulation of the training sample is a large and very complicated task, because this is not a trivial thing. Where can I have text feedback for courses where I know the tone exactly? Probably I should take feedback from last year's students and manually mark them up and put the badge whether I'm positive or not. Yes, this is a very time-consuming work, and it might sound ironically, yes, we're speaking about artificial intelligence now and things like that, but as the basis of all models machine learning is using and artificial intelligence is having as the basis for it is a training sample, and such samples are sometimes manually accumulated by people. They mark the images, they mark the texts, so much manual work to do for us to structure a smart intellectual model. But I think, well, it looks ironically in the era of AI. So we have such sample now. What should we do next? Usually the sample is used to check the error of the model, the loss function. If you want to Google it, it is called loss function. What is it? This is a measure of how efficient the model was in our sample. Yes, there are various loss functions, and when we study machine learning with my students, when I'm speaking about it, we spend 2 or 3 lectures to understand how loss functions can look like. And this is a large field, and new articles are published regularly. I'm giving you just one case. This is not the best case, not the best example, but anyway, for instance, I can do the following. I can take all objects of the train sample and look at what the model says, AX1, and I look at the proper answer. I deduct one from the other and then make a square of it. So if the right answer and what the model offers me coincides, then 0 is mistake. The mistake is 0. If it is more than 0, then the model is not effective enough. So that's how you can check the mistakes in one object, and then I sum up it across all objects, and that's the story I have at the end. This is the average square mistake, error, but I'm just showing you the concept. This is a very simple example indeed. And let's just look at another example. For instance, I have a model. It consists of two features. It takes two features as an input. How many times I see few in the text and cool in the text. I have two weights, W1, the ratio for few, and the another ratio for cool. And for instance, in my training sample, I have three texts.
This is less fun, cool course, and less sense. What will my loss function look like for this sample and for this curve? Let's look at the formula on the bottom of the slide. Let's discuss it. I take the first text, less fun. The word fun is not used in the model. I skip it. We use less. There's one hit. And the forecast will be W1. If we take cool as 0, less than 1, so double W1, it should be as close as possible to -1 because this feedback is negative. It should be -1. That's why I write W1 -1 square. This is the deviation, and the same procedure for all three texts. And what we get as a result, you can see this formula. We can see here the loss formula, the loss function, evaluating the formula is good or not. And what I don't know here in this function, I don't know the weights, W1 and W2. And our goal, our task is to find those weights. And the finding process in these optimal parameters is called learning. Machine learning means that I take the learning curve, I take some loss function, I take a certain model with unknown parameters, and I fine-tune those parameters in a way that the model would have less mistakes on the learning curve. That's what happens when they say that we train artificial intelligence. In the majority of cases, they solve this task. They take a bunch of parameters model, they take a sample, an error on the sample, and we fine-tune the parameters to make this error as less as possible, as low as possible. No super function, nothing complicated, not a big deal. Of course, we can take the analogy of human learning, but indeed, this is the optimization function. Sometimes they have implementation method course in universities. This is about how to find minimums in those functions. Okay, you got this function. We have some Q of W. We like to find W parameters to make it less as possible and to make the error as low as possible. How to do this? The question. I draw very bad pictures with my hand. When it's drawn by hand, it's even so neat and nice to look. It's closer to the human drawings. So let's take a simple example and have a look. How can we find the minimum of any functions? Basically, I have a function, any function, and let's imagine that my model depends only on one parameter at all. I have only one weight, W1, very strange model, but nevertheless, let's take it as an example. I want to have this parameter selected to make the function as less as possible. On X, we have W1. On Y-axis, we have Q from W1 and my loss function. And the graph is a little bit curved, right? At minimum is in the right side. This is the lowest point. How to find the minimum? Of course, we can take a precise look and say the minimum is there, but the computer is not able to do this. So we need to set some algorithm. Let us be based on the following idea. Probably you have already studied the function, the derivative function concept. The derivative function is a certain indicator of something. There is a point, and whether the function is growing and or dropping, and how strongly. We have the left branch where the function is descending, is getting less. The derivative will be less, and it's growing. The function is getting, And in this case, the derivative is higher, is plus. And this derivative will be different in value. You see this red dot, where the derivative will be negative, close to 0, because the changing function goes very slowly. And the dot on the right, marked with the second arrow, the derivative will be very high there, because the function is growing very fast. And the derivative shows how strong function is changing. And the idea is the following now. Let's take any dot, any random weight. For instance, 10. W1 will be equal 10. That's going to be the dot on the right, a red dot. I will calculate the derivative, and the derivative will tell me that here the function is going up, and it's going up strongly. But I'd like to find the minimum of my function, if you remember. On the right we see growing, but I want to have the dot which is less. So I have to go backwards to the left, and so the derivative tells me go left. And if the derivative is high, the function is going up, we can have bigger step. I take a bigger step, I see this new value, which is close to 0. You see where I've moved with the arrow, and this is my new dot, where I calculate the derivative. Once again, the function is going down, and this derivative is less. I move to the right, and so gradually I move one by one, and as a result I get to the minimum point. Probably we are so lucky, you may seem, that we got to the minimum point, but no, this hit can be confirmed by many theorems which say that under certain conditions this process can give you the right hit to this small range around the minimum dot. What should be the algorithm to find the minimum? The function was very simple, but what if the function was from two arguments? If I should find 2 points, W1 and W2, as in my initial example, the models with 2 parameters. In this case, I'm going to have the 3D graph. I have 2 axes, W1, W2, and the vertical axis tells me about the function value for these weights, for these parameters. As a result, let's say I have this arrow curve, which looks as a bowl, paraboloid, and let us try to find the minimum. The same algorithm again. I take certain point, W1 minus 5, W2 9. I have the set of parameters, and I got some point on the graph, and I have to move somewhere, shift to come closer to the minimum. There are a lot of directions to go: left, right, up, down. There are a lot of arrows marked here, and it turns out that it's possible to calculate, but not the derivative, but gradient. And the gradient shows that if you have a function, you can calculate the gradient, which tells you the direction where the function will grow as fast as possible. If you take the negative one, it will tell you where the function is descending. We calculate the shifts and move towards the minimum point. And the new violet dot, purple dot, shows us the new value, the minimum one, where we shift to. And so gradually moving, we sooner or later will get to the most minimum point. This is the gradient descent method. The idea is very simple. We take random weights, we calculate where to change them to make the function less, and by way of iteration, gradually shifting, changing the weights to make the function less and less. The idea is not complex, but it is in the basis of the most machine learning models. All those neural networks we are discussing today, which generate very natural languages, which recognize faces, objects on images, recognize human speech, all of them can be trained in this way. We take a set of parameters, and by moving it gradually, we can reduce the error. This is the key concept, not a big deal, not very complicated. So we discussed the machine learning. So machine learning is a model. We collect data, we select certain parameters to make the error as low as possible. Now let's discuss the following. Who would do this? Who will deal this? What kind of professions can be related to this? What specialists do when they solve those tasks? Of course, I won't be able to tell you about all the professions. There are a lot of work circling around it. Let's take some examples. For example, there are people, data engineers. These are not those who train models. These are people because of whom we have data to train models. These are specialists to collect and store data. These are people who are very well savvy with data, who are experts in data, who know how to store big data, who know technologies to collect data, to store them. And they build up all those processes. And this task is not so easy because one thing is when we analyze 500 feedbacks from students, this is very small data, and one specialist can do it by saving it on disk. But let's imagine that you have a huge online store where daily you have dozens, hundreds or thousands of orders. Each order is information. What was the user purchased, what he added to his basket, whatever. And this data should be captured in a real-time mode, should be securely stored. If some data center would go down, where you store this data anyway, you shouldn't lose those data. You need some replication, mirroring of data. It all requires serious technologies, and data engineers are dealing with this. This job is related to development and not just mathematics, but it's quite interesting and exciting. There are data scientists, so-called data scientists. These are people who take the steps which we've discussed initially a little bit. They select the loss function, they look at their learning curve, they select the model, they train the model, and let's discuss these steps. A data scientist is a person who works in a bank, and he gets a task to learn how to understand the fraud, how to detect fraud, to understand whether this person paying by card, is it his own card, or is it a thief who stole this card and now try to find it. So data scientist takes data from a database stored there by data engineer. Data scientist takes this data, studies it, and looks, we have these transactions. How many people are doing these transactions? What are the features which are characteristic for a fraudulent transaction? What kind of transactions are there and all? He asks a lot of questions. He studies data, formulates hypotheses, and afterwards he tries to build a model. He knows a huge amount of models where we're discussing just linear, but there are a bunch of others, metric models. There are trees, compositions of trees, neural networks, versatile, recurrent, scrolling, whatever. There are a lot of things. And data scientists should know it all and should select a proper model which will fit best to this task. After he built a model which works okay, of course he should prove that it works well, and it's normally done by experiments. How can this be done? For example, we can launch our model on the part of the bank's client and see is the rate of claim and complaint less or the same. We can see whether our model helps to prevent money theft or not. If it helps, so we see that it works on real users, we can accept this model and everything is good. These stages is the work of the data scientist. He should, of course, know the machine learning. He should know how to work with data, how to take a look at the data, how to visualize them. Of course, for that, he knows how to program. But of course, I imply that if you want to work with data, for sure you know how to write the code. The Python language is now the most popular one, and who knows what happens in a few years from now. Of course, data scientists should know mathematics. He should know mathematical statistics, because all those experiments on people, but whatever it sounds, when we try our model on different groups of our clients, you have to calculate it all. You have to make calculations if we see some improvement or deterioration. And not easy ways are done for that. Very good knowledge of statistics is needed. And to understand the machine learning, different mathematics is needed. For example, the learning process is a gradient descent. To understand very well how it works in deeply, you you be an expert of linear algebra or mathematics. There are a lot of probabilistic methods. Theory of probability needs to be there. So this training, this background is required. Just a few more things. Let's discuss a few more examples what data scientists can do. For example, there is a task to make a model to recognize faces. Let's say we want in our company to make an automated gateway. When the person enters the building, the camera reads his face and decides whether it's allowed to enter or not. And data scientists at once ask a lot of questions. Where can I get the data based on which I will learn the model? What loss functions should I have? How can we measure the specifics? Of course, it's very bad if we let in an unauthorized person, an alien. It would be very, very bad. What shall we do? How the model should be punished for this? It's much worse than we will not allow our student, our guy, but it is the unauthorized person would get in. This is as bad as possible. Based on the literature, he should understand what works best for face recognition. There are a lot of publications in this area. He needs to know how to find out the way there. In data science, there is a lot of literature, a lot of scientific articles, just to understand how these all should be solved now. New models should be changed a little bit, modified, and data scientists should bring some modifications and according to the specific tasks. There are a lot of other questions for data scientists. For example, credit scoring. When we understand for the bank client whether we can disburse a client or not, whether it will be repaid or not. It's a very common example for machine learning. Despite the fact that this is interesting for the models, it has a lot of other issues. For example, we have this model. It is being learned on a synthetic data, transactions, where persons pay for something. It turns out that these data about our life are used to train the model. There's a big branch now how to build this model if it comes to the hands of fraudsters, for instance, weights or parameters. The fraudsters won't be able to restore some sensitive information about our individual clients. This is very important to protect this data. So to avoid those leakages of information. It is very important to make sure that there are no shifts, no biases to some groups of people, and there is a lot of stuff to discuss. On top of that, there is the researcher. Researcher is a person who invents new methods. If a data scientist solves interesting business tasks by ready-made methods, by adjusting them, the researcher invents those new methods. And basically, there are a lot of tasks where the quality is suboptimal, and the researchers should improve the quality. They have to know machine learning. They have to be very good experts in mathematics, because different results from mathematics could be used to invent something new. Very often, researchers take knowledge from other branches. A lot of machine learning being researched by using knowledge from physics, from mathematics, so the wide knowledge and experience is very useful there. If we speak what is the main focus for researchers, this slide is very scarce. A lot of scientists is in our area, a lot of tasks. Just a few examples. Researchers are dealing with autonomous vehicles, unmanned vehicles. There's no ready-made solution for that. There's no vehicle which could drive the street absolutely without human intervention. They are dealing with voice recognition, speech recognition, building up dialogue systems to communicate with users and look like a real person, a human person. There are a lot of tasks with biologic. biology. For instance, data or genetic data analysis is used machine learning to find proper regularities and a lot of other things. And there is a machine learning engineer, another profession. These are people who implement models, deploy them. One thing is when we invented a model to make good search engine like Yandex or Google. Another thing is to program the model, to build it in a way that it works very fast, fail-safe. And if there are 500,000 users a second would use it, the site should work, should not fail. And there's a huge amount of engineering tasks come up. How to take a model of a machine learning and how to implement it in a way to make it work very efficiently and very good.
These specialists are in demand today. They should be experts in machine learning and the distributed systems and algorithms and data structures to write effective code. So they are working in all these areas. So I told you a couple of words about what machine learning is all about, in what areas and what fields you can work and what specialists are operating in this industry. If you're interested, then there are a lot of approaches to study this subject. There are a lot of courses around, and I can actually offer our specialization in Coursera. Me and my colleagues are preparing material for it, machine learning in statistics and neural networks. If you scan this QR code, you can get to the program, to the course. These are my contact details. If you're interested, please contact me. I will be happy to answer your questions. Thank you very much for your attention.